This is lesson 12.4 on quadrilaterals. So our goal today is mainly how to understand classification of quadrilaterals and how to do a little bit of computational work with quadrilaterals as well. Now, first off, quadrilaterals is basically any four-sided shape like this one here. Anything with a closed figure with four sides is considered a quadrilateral, thus the prefix quad. And so like we discussed in class, that if you start changing certain characteristics about the quadrilateral, that we start to create all these categories. So this, what I'm about to show here, is the chart that pretty much our groups came up with in class. So here's the first one. If you take your quadrilateral and you change it so that exactly one pair of sides is parallel, well, then that becomes a trapezoid. So from quadrilateral, the most generic form of a four-sided shape, we specialize it just a little bit so that it has two and only two parallel sides. Okay. Now, over here, we get something called a kite. And you can see why they call it a kite. It looks like one of those old-fashioned kites you see, in a show, or maybe you've flown one yourself, where this pair of adjacent sides and this pair of adjacent sides are congruent. And now the reason I mention these first is because if you'll notice on our chart, these just kind of dead end. They go from the quadrilateral, they come on down, and then boom, trapezoid. But then there's nothing else in the trapezoid category. A trapezoid is its own kind of standalone shape. Same thing with a kite. But then if I go from quadrilateral to here, there's some continuation. So in the middle here we have parallelogram, and a parallelogram is similar to a trapezoid, but in the sense that it's both pairs of sides are parallel. These two sides are parallel, and these two sides are parallel. And since this pair is parallel and this pair is parallel, it also means that those sides are congruent. So this left side is the same length as the right side. This top side is the same thing as the bottom. All right, but you'll notice here that parallelogram branches off further, that I can take a parallelogram shape and specialize it even further. So let's go to the left here. So here we get a shape we're much more familiar with, is that we get a rectangle. And if you think about it, a rectangle is a parallelogram. That's why it falls underneath it on the chart. It's because it's got one pair of parallel sides, two pairs of parallel sides, and these sides are congruent and those sides are congruent. Now the only way that a rectangle is a more special type of parallelogram is that it's also got four right angles. So a rectangle is a parallelogram and is a quadrilateral. But then a trapezoid is only quadrilateral. So that's why trapezoid's kind of off here, dead ending, and same thing with our kite. All right, now parallelogram, if we branch off in a different way, I'm going to have to move this a little bit here. Ignore this bottom one for now. If we take a parallelogram but then change special characteristics about it differently from how we did the rectangle, we get a rhombus. So notice, it's still a parallelogram. These two sides are parallel, these two sides are parallel, and the only difference is, instead of just this pair or this pair being congruent, all four sides are congruent. In fact, you get, layman's terms, we get a diamond. All right, but we call that a rhombus. So now, finally, we get to probably the most familiar one of all, which is if we take the characteristics of a rectangle, which is a parallelogram with 90-degree angles, and we take a rhombus, a parallelogram with four equal sides, and we combine those two pieces, we get the most specialized quadrilateral of all, a square. And so this is the flow chart when it comes to quadrilaterals, from the most generic, quadrilateral four sides, all the way down to a square, which has the most amount of specialized characteristics. All right, so when you're classifying things, you use this chart. So if I say I give you a rhombus, well, a rhombus is also a parallelogram and it's also a quadrilateral. If I give you this shape, well, that's a square, but that square also counts as a rectangle, as a rhombus, as a parallelogram, and as a quadrilateral. If I give you this shape, well, that shape's a kite and a quadrilateral, but nothing else. And so this is the way we organize the family of quadrilaterals. All right, now the other thing, these are a little out of order here, to know is that when it comes to quadrilaterals, that the angle measures of any quadrilateral, and it doesn't mention here the interior, always adds up to 360 degrees. That it doesn't matter which of these shapes I choose, that they all add up to 360 degrees on the interior angles. So probably the easiest one to show this is a square. 90 degrees, 90 degrees, 90 degrees, 90 degrees. 90 times 4, that's 360. Now, even though I don't know the measurements over here on this trapezoid, if I were to take this measurement plus this one, plus this one, plus this one, that would be 360 degrees. And in fact, I could do it on this one right here, the quadrilateral. This angle plus this angle plus this one is 360. So no matter what quadrilateral you're looking at, the sum of the angle measures is always 360. And so where you're going to use that is problems like this, where we take a bit of algebra and geometry and mix the two together. So let's say I've got a missing angle, but I've got the other three. Well, knowing that this is a four-sided quadrilateral, we can figure it out. And we just basically come up with something like this. We've got 81 degrees, which is this corner. This one, a right angle, so that's 90 degrees. This angle, which is 124, plus our missing angle x. And since this is a quadrilateral, we know that these added together should add up to 360. So we can simplify and solve and find that missing angle. So let's see, this is 1 plus 0 plus 4, that's 5. 2 plus 9, that's 11. Plus 8, that's 19. Plus the 1, so that's 295. Plus x equals 360. Solve the equation by subtracting 295 from both sides. So x equals 65 degrees. So this angle right here, 65 degrees. All right, so that's the information we need to know about quadrilaterals, that we have an organizational flowchart which tells us all the different types of quadrilaterals and how they do or don't relate to one another, and the fact that no matter which quadrilateral it is, that the angle measures of the interior always add up to 360 degrees. All right, so this is the information you're going to need to work with quadrilaterals.